So we'll get started with the AP Physics C Mechanics. Okay, I'll just be talking from a general point of view. Let me start this presentation. Okay. So the College Board's Advanced Placement Program enables students to pursue college level studies while still in high school. We know that. The physics course in particular plays a major role for all the students who are opting for specifically the engineering courses and all the courses which are related to core sciences, all the STEM. Basically, physics is a part of the STEM courses, so a very important subject. A lot of students opt for physics in their standard 11th and 12th when they are studying. And we have the AP testing the physics at a higher level, that is at level 11 and 12, via two subjects. One of them is the AP Physics C Mechanics course. Now, it's a one-semester calculus-based college-level physics course, especially appropriate for students planning to specialize or major in one of the physical sciences or engineering. This course is the first of a two-course sequence that is equivalent to the introductory physics sequence taken by science and engineering students at most of the colleges and universities. The first one is this AP Physics C Mechanics. The second one is the APC Physics Electricity and Magnetism. So it's a part of this two-course sequence. What is covered in this exam? Okay, so we'll briefly talk about the syllabus. It is a calculus-based physics course. This is one major difference that the students need to understand. There are other AP Physics examinations as well. For example, there is a AP Physics 1, which is algebra-based. This one is calculus-based. Okay, so one of the primary requirements from the student's perspective is that the student either should have done some calculus course already or must be parallelly enrolled with a calculus course. So it's a calculus-based physics course. It covers the basic topics of kinematics, dynamics, energy, momentum, rotational motion, gravitation, and oscillations. Okay, the students cultivate their understanding of physics through classroom study and activities as well as the hands-on lab work. So obviously the exam goes parallelly with the lab work that the students do at their schools. Okay, they explore concepts such as the changes and force interactions, fields, conservation of momentum, conservation of energy, and all types of problems related to force analysis and motion analysis. So broadly, it is force and motion, if I can use two words as far as this particular course is concerned. Okay, the prerequisites, students should have taken or be concurrently taking calculus. Now, this is very important. Most of the formula-based derivations or most of the results that we go through, they require a good understanding of the calculus-based concepts. A lot of problems also required a good hold over calculus as a subject, both differential as well as integral. So calculus is a primary requirement. The lab requirements, as the students would explore, is a hands-on lab component comparable to a semester-long introductory college-level physics lab course, which they obviously do. If they opt for physics, they do this at their schools. Okay, they should spend a minimum of 25% of the instructional time on the lab work, which obviously the school ensures that they do. Students can ask questions, observations, predictions, design experiments, analysis of data, construct arguments in a collaborative setting. They direct and monitor their progress. Again, all of this is related to their lab work. The course content, this is very important. As you can see, the entire course has been divided into 7 units. Okay. Unit 1 is kinematics. The exam weighting is approximately 14% to 20% of the total questions. Then we have the second unit, which is the Newton's law of motion or the dynamics part from the mechanics syllabus. The third unit is work, power, and energy. The fourth unit is considered to be slightly easier compared to the first three, the conservation of momentum principle. Then the most difficult unit, as they say in mechanics, the rotational motion. Then finally, there are small units which are clubbed, actually 6 and 7. Usually you get one question each. So oscillations and gravitation. So a combined weightage of 6 plus 7 is equal to the other 5 units. As you can see, roughly all of them have almost a similar weightage between 15 and 20%. Okay. Exam structure, it's a 1 hour 30 minutes exam. Okay, it assesses the students' application of the science practices. So most of the problems that the students are likely to see, they are basically related to some practical situation. Understanding of the learning objectives outlined in the course framework. So if they can go through the College Board website, the AP Central website, they have a dedicated page for this learning objectives given on that page. They should go through it, sincere suggestion. Okay, so 1 hour 30 minutes include 35 multiple choice questions, that is section 1. And section 2 is 3 free response questions. Now, these free response questions are basically descriptive answer questions where a student has to elaborate his solution to a given problem. So all the steps carry marks here. Whereas obviously the MCQs, he just has to pick the correct option and he gets full marks. Okay, so both the aspects, the MCQ as well as the FRQ, it has equal weightage in the test. Although you can see there is a huge difference in the number of questions, but the weightage for both the sections is equal. Okay, so FRQs, the answers or the solutions actually have to be really elaborate. Step-by-step solutions will get good marks. And for that, a student has to learn actually how to write a solution. Okay, so those steps in the solutions are very critical. So as far as the MCQs are concerned, the speed is very important. As far as the FRQs are concerned, writing a detailed solution is very important. So he should be adept at both the skills. A 4-function scientific or a graphing calculator is allowed on both the sections of exam. So obviously, the College Board is not trying to test your calculation. Okay? They allow the calculator for the entire duration of the test. So both the sections, the student is free to use the calculator. The assessment format, as I said, multiple choice questions, there are 35. Total time allocated is 45 minutes. It contributes to 50% of the examination score. Okay. Now, again, these science practices have been mentioned explicitly on the website. My suggestion, again, students should go through these science practices. It is a separate page mentioned on the AP Physics C Mechanics page. Okay. And section 2, as I said, is free response. Again, 45 minutes and 50% of the weightage is for this FRQ. Now, one of the 3 questions that is there in the FRQ is an experimental or a lab-based question. So again, how students do in their laboratory coursework, this one question would be very, very important because it is exactly on the pattern of how they perform experiments in the laboratory. Okay, each question in the FRQ section is 15 points. So the 3 questions contribute to 45 points. Now, the number of points for the MCQs is not known, but it is known that they contribute equally. So we can assume that the 35 questions will again contribute to 45 points. So overall 90 points for the test. Obviously, it's a graded exam and the final scores are also relatively graded. These are few sample questions. As you can see, this is a question, as you can see, related to the force equation. And again, if you want to find out solution to this, calculus would be required, as students would understand when they solve this question. So let me highlight this point here again, that you need to really have a grip on calculus if you want to do well in the Physics C Mechanics as well as Physics C Electricity course. Again, these are just some sample questions. You'll see there are 5 options for each of the questions. Okay, 35 questions in 45 minutes. The bigger challenges I've already mentioned is the speed. Okay, you get roughly, you can say, a minute per question. That's all you get. So you have to be really quick in this section and you have to quickly come to the right answers. Now, obviously, these are 2 very different skills, how to quickly get to an answer and how to write a detailed solution. So that is why I said a student must be adept at both these skills and he has to learn both the skills if he really wants to do well on this paper. Now, these are some FRQ questions, as you can see. Usually these questions would be very long questions, very long in the sense it would be one question, but there would be multiple parts of the same question. So it would be like 1A, 1B, 1C, 1D, 1E, 1F, 1G. So there could be like 7 or 8 questions within one question. That is why you get 15 points for each of these questions. The solutions, as I said, these are some scoring guidelines. So as you can see, for that particular question, this is how a typical solution would be written. So you see first step, they give you 1 point. If you correctly write the second one, they give you 1 more point. So total points, 2 points for part A. Similarly, you see 1 point, 1 point, 1 point. So 3 points for part B. And like that, you have the total marks being allocated. So every single step is important as far as the free response questions are concerned. The student should never miss any important steps of the solutions when they are writing these solutions. Okay, they really have to be detailed. All right. I just quickly move through this thing. Right, now coming to, sorry, this is 2022 conduction. Okay, there is some error. It is going to be on 10th May 2022, 12 p.m. local time. This is the first administration. And then 19th May would be the late conduction, again 12 p.m. local time. Now, late conduction, please, you should know one thing, that there has to be strong grounds for appearing in the late conduction. You must provide some valid reasons that why you cannot appear in the first administration and why you have want to go for the second one. So they have actually on their website listed the reasons where you can, take the second conduction. So it really has to be a strong reason, and your AP coordinator at your respective schools, they must be convinced that, okay, that is why you need to take the second administration. But both the administrations here, 10th and 19th May, 12 p.m. local time. I think the enrollments for the AP courses have already started. So those of you who are actually interested in taking the physics course, this is one suggestion: you should get enrolled as early as possible, because later on the slots, they become a problem. So not everybody gets the slots. Preparation timeline and the resources. Syllabus mostly overlaps the standard 11 syllabus of various boards as far as the mechanics course is concerned. In fact, some small parts are in fact taught in standard 10th as well. So ideally, this is the AP for students who are either in 10th and going to 11th, or who are in standard 11th. Okay, this is very ideal for those students. If you're already in 12th, you can still take it if you haven't taken it. But 10th and 11th is the right time to take it, because by the time you are in 12th, I would always recommend that you take the other one, which is the electricity and magnetism. Okay, because electricity magnetism usually is taught in standard 12th. So I think when you're in 12th, you can take the other one as well. As I have already mentioned, these are like connected. I mean, usually one in one semester, the other in the second one. So if you really want to pursue engineering courses or courses where physics is important, you should take both of them. Ideally at the end of standard 11th. Okay, it takes about 30 to 40 hours to completely prepare for the exam. Now, basically, when I say 30 to 40 hours, I mean completing the syllabus. Now, obviously, any number of preparation you can always put in. Okay, but 30 to 40 hours is bare minimum to just cover the syllabus. If you want to do further practice, obviously, you should be putting in more number of hours. You can distribute your preparation evenly throughout your standard 11 studies as per your convenience. But my suggestion would be, if you get enrolled now, right from now on onwards till the month of May, you should actually be doing some preparation every month. Okay, don't keep it for the very end that you just get enrolled now and then start preparing in March or somewhere mid-March something. I believe that you would be not prepared, or you would be under-prepared for the test if you start preparing late. Okay, so if you are getting enrolled now, start preparing now, so that by the time it is May, 4 to 5 months is a very good time. You can, as I said, you can space out the preparation evenly, and you could achieve that level of preparation which is required by the time it is your exam. Books from reputed publishers, the resources. Okay, so you have all the major publishers publishing their books for the AP physics course. There is Barron's, there is Kaplan, okay, there is Peterson. Everybody is publishing their books, so all of them are obviously available. The AP Central website is the best resource for the past papers, so you can just download those papers from the AP Central website. The free response questions are all available. And reference books such as Paul Tipler, Resnick Halliday Walker, or Sierz-Zimanski University Physics. These are common books usually students do follow when they are in standard 11, 12th. So all of these books are also good with their problems and all. Okay, now this basically is a very application oriented paper. So mind you, your problem solving ability is something that would get tested to the core. So please be very clear that this is not going to be a theoretical exam. This is going to be totally problem oriented. You should be actually good at numericals or problem solving. So that is the skill that they are testing in this particular exam. So you need to have sufficient practice as far as number of problems are concerned. Every topic, I would broadly suggest that you solve at least 50 problems per topic. So if there are 7 units, you should have at least done 350, 400 problems at least, okay, to have a grip over the examination. Okay, as I have already mentioned, the AP website is a good source for all the previous year's questions. So doing those questions is also a good practice, but to get to that level, okay, you would take some time. So that is why I said start early, so that you can space out your preparation till the till that point when you are actually appearing for the test. Okay, Khan Academy is obviously the website to follow. And I think that's about it from my side. So APs in physics, as I've already mentioned one thing, okay, they test fundamental concepts. Okay, so if you're preparing for the APs, try to get into the depth of the concept. As you can see, the width here is quite restricted. Okay, all these units, as far as, for example, we're talking about the mechanics thing here, only 6 units. Usually you would see that in any school, these 6 units would be done within 2 months or 3 months at max, right? So the width is very restricted, but for the AP, I would strongly recommend get to the depth of the concept. That is why even you see the books that I have recommended there, for example, the Paul Tipler book or the Sierz-Zimanski book, they take you to the depth of the subject. Don't just study it superficially. That is not going to help for the APA. The problems will really test the conceptual knowledge. So try to develop sound concepts using some good literature for the subject which is already available. So try to get to the depth of the subject, and I'm sure you can then handle the exam very well.